Hi, this is Professor Fernandez, and in this video we are going to work on the rules of exponents. The example that we're going to do here is example 8.8 from the appendix A from the book Calculus Simplified. So the first one we're going to do here is simplifying the expression 2 to the third times 2 to the fifth. So to do this, we are going to use one of the rules of exponents that says that when I have the same base, so 2 here is the base of each of these numbers, 2 to the third, 2 to the fifth. When I have the same base, I keep the base and then I just add the exponents. So I would be adding 3 and 5 here. So that would give me 2 to the eighth, and that is my answer. We could certainly multiply this out. This is 2 multiplied by itself 8 times, but there's really no reason to do that. 2 to the eighth is a perfectly good answer here. So let's look at part B here. To do this, we are going to, we're being asked to cube the product of x squared with square root of y. So the property of exponents we're going to use here is that this cubing is going to apply now to both x squared and to the square root of y. So that's the first property we'll use. Next property we'll use here, let's take it step by step. X squared cubed. Here you have x squared raised to the third. You could think of this as x squared times x squared times x squared. That's what cubing means, right? You multiply the object, number, variable, whatever, by itself 3 times. And then you could use the operation that we just talked about. Each one of these has the same base, so we add the exponents. So that would give us x to the 6. So that's one way to understand why this ends up being x to the 6. Or you could use another property, another rule of exponents, which is now we have x raised to a power itself raised to another power. In that case, we multiply these two. So that would give us x to the 6. So same outcome, 2 different ways. Whichever way works better for you is best. And then now let's look at the next part of this expression, which is square root of y cubed. Various ways to do that, but probably the best one in terms of using rules of exponents is to write square root of y as y to the 1/2. The reason is that now we are doing y to the 1/2 raised to the third. So again, we could view this as y to the 1/2 times y to the 1/2 times y to the 1/2, and then get y to the 1/2 plus 1/2 plus 1/2, which would be y to the 3/2. Or we could apply the shortcut we kind of just did. We said, okay, I'm raising something, y to the 1/2, and then I'm raising that to the third, so I just multiply these two numbers together. Y to the 1/2 times 3, and that goes back to the earlier video where we learned how to multiply fractions, so we just multiply straight across. We would have y to the 3/2. Again, we get the same endpoint, so we're going to put y to the 3/2 here. We could leave that as is, but in the interest of helping you remember some of these properties, y to the 3/2 can be written as y to the third square root, right? So the square root sign, if it doesn't have a number here called the index, you assume that it's 2, and that 2 becomes the denominator of the fractional expression of this radical. So this is square root of y cubed. We could also write it another way. We could recognize that y to the 3/2 is y to the 2 over 2 plus 1 over 2. In other words, y to the 1 plus 1/2, which is y to the first times y to the 1/2. So this is y square root of y. Okay, so that is also something we could have recognized from here and said, oh, this is square root of y squared times y. And square root of y squared, if we're not given information about domain or we're not thinking that far in terms of functions, square root of y squared is just y, and then we would have a square root of y left over. So same ending point again. Okay, so I've done all of this to help you see how these various rules of exponents are being used and could be used to review and understand lots of different concepts that you might have covered in algebra at some point. But either way, whichever mix of these things you use, right, you'll get to this answer in its, potentially most simplified form. Okay, so that was part B. So now let's look at part C. Let's make a little space for ourselves here. So in part A and B, we were working mostly with the rules of exponents that have to do with being raised to a power and then how that interacts with multiplication. So the point of example C is to do all of this, but now for throwing in division as well. So let's look at this expression. So we have x squared over the third root of y squared, and we are going to cube all of this. The first thing to know here is that one of the rules of exponents says that when you are raising a fraction to a power, you raise the numerator and the denominator of the fraction to the same power. So we are now going to do this as our first step. Okay, from here you have various options. We'll just do the numerator. X squared cubed, like we talked about before, that is multiply the 2 and 3, we get x to the 6. In terms of the denominator, so like we did before, it pays to write this radical in fractional form as y squared, y to the 2/3. Okay, so the index here is 3, that becomes the new denominator. Okay, so now we have that rewritten, but we're still cubing it. So we're going to keep our x to the 6, and then downstairs we have y to the 2/3 raised to the 3rd. So again, we're going to multiply these two numbers. So 2/3 times 3 over 1. We multiply right across, we get 6 over 3, that's 2. You might have also learned that when you're multiplying numbers together or expressions, you can cancel if the numbers or variables or whatever they are on opposite sides. One of them is a numerator, one of them is a denominator, or vice versa. So again, that would give us the same answer here, which is 2. So our denominator over here is y squared. And that is our most simplified expression. So x to the 6, y squared, is what we would simplify this original ugly mess to. Okay, so now let's do the last example, which is in some sense the trickiest one because there's a lot more going on, even though it might not seem like that. Okay, so let's look at part D. This one says x to the negative 1. So that's the first place where we want to start. So rules of exponents tell us that if we raise a variable to a negative number, we turn that variable into a reciprocal. So x to the negative 1 is 1 over x. X to the negative 7 would be 1 over x to the 7th, for example. Okay, so I'm just going to take it step by step here. And then if I want to keep simplifying this, right, I could find a common denominator here in the numerator. So this is something that we talked about in one of the videos of adding fractions. So if I want to add 1 over x and x, right, I need to find a common denominator. Well, x can be written as x over 1. And then like I suggested in that video, one of the earlier videos, the easiest thing to do usually is just to multiply the denominators together. In this case, I multiply x and 1, and I just get x. And then we can use our simple cross multiplication trick. So 1 times 1, that's 1. X times x, that's x squared, and we keep the sign. So 1 over x plus x equals 1 plus x squared over x. Then I will take that and plop it in over here in the numerator, 1 plus x squared over x. All right, and then now I have the fun task of taking 1 plus x squared over x and dividing it by x plus y. So in that same video I keep referring to where we talked about the addition, subtraction, multiplication, division of fractions, we talked about how when you divide two fractions, and this is still a fraction, doesn't seem like it, but it is, you are actually going to multiply by the reciprocal. So we get 1 plus x squared over x here, and then we're going to multiply by the reciprocal. Oops, let me not put an x. Okay, the reciprocal of this, which literally just swaps numerator and denominator. So we get 1 over x plus y. So our final answer, now we multiply straight across, is 1 plus x squared over x times x plus y. Great. So at this point we did all 4 of these, and we hopefully illustrated all the different rules of exponents that come into play, which are all going to be very helpful later on when we start doing some of the calculus topics in the course.